All right, here's three great log questions. This first is a little tougher one. I like it. Okay, so question number 13. So 9 is equal to 3 to the 3x times 9 to the x squared. Okay, it'd be nice to get everything to the same base. So why don't we change this 9 to 3 squared is equal to 3. That one's already a 3, so I'll leave that. Times this 9, let's change it to 3 squared to the x squared. Okay, let's deal with this here. That's power by power. So you multiply. So it'd be 3 to the 2 times x squared, or 2x squared. Okay, now these are the same base and I'm multiplying, so I can add exponents. So it'd be 3 to the 3x plus 2x squared is equal to 3 squared. Okay, going good. Now I have the same base, so I can drop the base and equate the exponents. So it'll be 2 is equal to 3x plus 2x squared. Now I've got a quadratic. So let's go over here and solve it. I'm going to bring everything over to the right side. And I'll reorder it. So 2x squared is first, plus 3x. And then if I bring the 2 over, it'll become negative. Okay, now I have a quadratic. I'm hoping I can factor this. If I can't, I'll have to use a quadratic formula. I'm just going to do guess and check. So 2x, I'm thinking maybe a plus 4, no, not plus 4, plus 2, because I have to multiply the 2, right? So plus 2 and a negative 1. Let's check that. 2x squared, yep. Plus 4x minus 1x gives me 3x, minus 1 times 2, minus 2. Yeah, so it's correct. Okay, so now that I've factored it, it's equal to 0. So either 2x minus 1 is 0 or x plus 2 is 0. So in this case, I'll add 1 to both sides, divide both sides by 2. In this case, just subtract 2 from each side. So I come up with the answer of 1/2 and negative 2. I wonder if that'll work. The negative 2 one I worry about. Let's try. You can always check it. I'll just check the negative 2 one because I'm a little worried about it. So 9 is equal to 3 to the 3 times minus 2 times 9 to the negative 2 squared. Okay, I have 9 equals, this would be 3 to the negative 6 times 9. Negative 2 squared would be a positive 4. Let's change this 9 to a 3 squared. Minus 6 times, well, I think it's going to work. 9 is the same thing as 3 squared to the 4th. And then 3 to the negative 6 times 3 power, so I multiply, 8. And when you're multiplying common bases, add their exponents. Negative 6 plus 8 is a positive 2. Yeah, that one works. So negative 2 works. You could check out the half as well. Let's try another question. Here's one that's a little bit easier. So log base 2 of that. So I need to squish these two together. Since that's an add, I'll use the product rule. So it'll be log base 2 of the product of x plus 3 times x minus 3 is equal to 3. Once I've squished, now I can change it to exponential form. Here's my base, so 2 to the, that's the exponent, third, is equal to this stuff. X plus 3, x minus 3. 2 to the third, careful with that, is 8, is equal to, here when I FOIL, I'll get x squared minus 3x plus 3x minus 9. Cancel. 8 equals x squared minus 9. Then at this point, I'll add 9 to this side, add 9 to this side. So I get x squared is equal to 17. And then I'll take the square root of both sides. Just x. And this I should write as plus and minus. Okay, now, I think I'm good with that, but I'm worried about this minus. Like root 17 is like 4 point something or other. So let me just check if negative 4 point something or other would work in there. If I put a negative in right there or a negative into there, with the stuff in brackets, I'm going to get a negative number, and you can't take the log of a negative number. So I would cancel out the minus part of that and just say my answer is a positive root 17. One couple worded problems. Carbon 14 has a half-life of P5750. Okay, so let's put our formula out here. P of t equals P0 e to the kt. So they're telling me half-life 5750 years. Scientists had discovered an artifact that had lost 24.7. How old was it? Oh, okay. Well, in this one, I'm going to have to figure out what my K value is, and then I'll figure out the rest. Okay, so they say half-life. That means if I start at 10 grams of something, that after 5750 years, it's going to be half of that. So it starts at 10, it ends at 5. Okay, K I don't know, but the time I know is 5750. Here I've got an exponential equation. To solve it, I need to isolate this part. This is times, so I'm going to divide both sides by 10. And so on this side, I come up with a half is equal to e to the k times 5750. Notice it doesn't matter what number you start with here. As long as this one's half of it, you're always going to come up with that half there. Okay, now since I have an exponent that's a variable, I need to change this to log form. So it'd be log base e of 1/2 is equal to k times 5750. Life is good here. Log base e is the same as ln. So ln, I'm just going to change the decimals here for a second. Ln of 0.5 is equal to k times 5750. Divide both sides by 5750. So k is equal to, let me get my calculator. Okay, so from that I get negative 0.0001205 and some other stuff. Okay, so that's my k value. So that's how much the substance, whatever, the radioactive thing, is decaying by. And it's minus, so it's going down, so that's good. Okay, so now let's look at the next part of the question. I'll do it in red. So they say they discovered an artifact had lost 24% of its carbon-14. How old was the artifact? Okay, so this tells me they've lost that much, so they must have started at 100. That'll be my P0. If they lose 24.7, that's got to be 75.3 will be remaining. That'll be my P of t. Okay, so let's do our P of t, P0 e to the kt. So I'm winding up with 75.3 because I lost that much. I'm starting at 100% e. My k value, negative 0.0001205, etc. t. So they want to know how old the artifact is. I'm looking for t. Life is good. Divide both sides by 100, so I'll get 0.753 is equal to e to the negative 0.0001205t. Change to log form, so log base e of 0.753 is going to be equal to negative 0.0001205t. To divide, then I'll divide. So this will be ln of 0.753 divided by negative 0.0001205. Okay, I've got an old calculator. Oh, let me try decimals. I'll put the answer in just a sec. Okay, I think my calculator gave me 2353.349. So I'd call it 2353 years old. That's how old the artifact is. Yeah. Okay, last question, another worded one. Let's hope this one's easier. Kimberly invests $7,000 in her savings account, 5 years, P0, this would be T. When she withdrew it, she had that much. That's 5 years. Well, that's pretty good, $1,400 for 5 years. Interest was compounded continuously. So if it's continuously, I get to use this guy, e to the kt. If it was compounded quarterly or monthly or yearly, then I'd have to use that other formula, that one. But I get to use this one because it says continuously. So end up with 8422.53, starting with 7,000, E, K, interest rate. Oh, I don't know the interest rate. K, and it's for 5 years, so it'll be a 5 there. All right, same as all the other questions that we've done here 2 or 3 times already. Divide both sides by 7,000. So you get e to the k times 5 is equal to this. I'm just going to leave that number right there. Change the log form. Log base e of 8422.53 over 7,000 is equal to k times 5. So I'm going to figure out this stuff on the left and then divide everything by 5. I'll just do that all on my machine right now. Okay, when I do that, I come up with a k value of 0.037 and a bunch of zeros after it. So that will be my growth rate constant. If you change it to a percentage by timesing it by 100, 0.037 times 100, you're going to have 3.7%. That'll be your interest rate to get you the $8,400 when you start with 7,000. Hopefully that helps you with those 4 questions. Good ones.